In this lesson, we will discuss box plots. In last lesson, we had discussed pie charts, so I highly recommend please watch that video first, then it will be much more clear to you. So what is the box plot? Here I have written some information. Box plot is also called 5 points plot. A box plot is a way of statistically representing the distribution of data through 5 main dimensions, and these dimensions are minimum value, the maximum value, first quartile, second quartile, and third quartile. Now, what are the meanings of this? Whatever data set you have, first of all you have to arrange in order. If you like, you can arrange in ascending order or descending order, right? First of all, you have to find out what is the minimum value of that data set. So smallest number in the data set excluding the outliers. So what is the outliers now? Suppose we have some numbers. If I will say 100, 150, 200, 220, 320, right? So these all numbers are close. Suddenly the next number comes, which is 5000. So it is too far away from our data set, which is 300 and 200 and 500, whatever, right? So it is called the outliers. So outliers can be in both direction. Suppose if we have a data set in which we have 1000, first number is 1000, then 1500, 2000, and so on, right? But the first number is 1. So 1 is the outlier because after 1 we have 1000. So minimum number you have to find out is smallest number in the data set excluding the outliers. I will show you how you have to calculate outliers in this video as well. And then maximum value, the highest number in the data set excluding the outliers. First quartile is the middle number between the minimum and the median. Okay, first I will discuss this second quartile, which is called the median, and median is the center value of your data set. If you have the odd numbers, right? If you have 7 numbers, any number, 5, 6, 7, 8, 9, 10, 11, anyone, right? So the center, if you have a odd number set, then you have only one number in the center, that is called the median or the center value, or Q2, quartile 2. And quartile 1 is middle number between the minimum value, whatever is the minimum value, whatever is your median. The center value is called the first quartile. First quartile is also called 25% of data, second quartile is 50% of data, and third quartile is the 75% of data. Third quartile is the middle number between median and the maximum number. So I hope this is clear, but I will give you the link of my statistics video, which is based on the box plot. In this way, you will learn more. So here I have written some information how to make the box plot. To make a box plot, we can use kind is equal to box, right? Last time when we were making the pie charts, we were writing kind is equal to pi. In case of line, we said kind is equal to line. So please write down only box. There is no need to write down the box plot. Kind is equal to box in plot method invoked on the pandas series or pandas data frame. Pandas series and pandas data frame we have discussed so many times in my fundamental of Python course, but I will explain to you here again. Let's plot the box plot for Japanese immigrants, the same data file I am using in this course, which is based on immigration. The file name is Immigration to Canada from 1980 to 2013. Same file I am using here, right? In this, in order to make the box plot, first of all I am going to use Japanese immigrants between 1980 to 2013. So only there are two steps to make the box plot. First one is get the data set. First of all, we have to check the Japanese data set from 1980 to 2013. So even though we are extracting the data for just one country, see only one country, we will obtain it as a data frame. Why? Because this will help us with calling the data frame dot describe function, and describe function will give us all the statistical measures, right? Quartile 1, 2, 3, mean, and everything I will show you here again. So this is our initial database or data frame name when we had started this course, can underscore immigration. It is Canadian immigration. Dot log function we have to use. Even though we are using only one country, you have to use two square bracket. I have mentioned here why, right? And then years. What is years? Year is my variable which I had created in the last lesson. That is why I highly recommend to watch that video as well. I will give the link in the description section as well. And then I said, instead of writing all this again and again, I said my data frame name is df underscore Japan. If I want to check the first 5 records, because we are using head, you can see only one record is here. Why? Because there is only one time Japan, right? We are dealing with Japan, and these are all the years immigrants from 1980 to 2013. Okay, now our second step is to make a plot. So simple. First we have to check the data frame and then make the graph box plot. So df underscore Japan, how you have to write down the syntax? Dot plot. Only dot plot. In parentheses write down kind is equal to box. This is the figure size, width and height it will show you. If you want, you can write down the color as well, which I will show you in the next coding as well. This is the very basic. Plt dot title, because this is the scripting layer. Plt dot y label, whatever name you can write down here. When I will run this function, this coding, what you think? There should be a box plot, yes or no? You will see amazing thing will happen here. I will show you. Asterisk sign means it is working. See, where is my box plot? What is this, right? Why it happened, I will show you here one more time. Actually we had discussed in the last lesson as well, but here I will show you. After that I will not use it. Okay, I am going to explain. See here, in this case, my country, this country Japan is my index. That is why it happened. I want all this year should be considered as an index. So what you have to do when we are going to transfer or make row as a column, it is called the transpose. Only we have to take the transpose here. Everything exact same from here to here. Just write down dot transpose method. And when I will run it, you will see now instead of Japan, now we have the years here. In 1980, 701 people were migrated from Japan, and so on. Right? Okay. Now you will see that these are only top 5. If you want, I will show you 10, right? From 1980 and so on. But when we will make the graph, it will consider all the years from 1980 to 2013. Okay, now same. Our second step is to make a plot. Everything is same here. Whatever I did in the beginning, just execute after taking the transpose, and you will see now we have a very nice box plot. And we can read this box plot very easily. What is the meaning of this box plot? As I said earlier, that it is also called the 5-point plots. This is the minimum value. So here we can say, even though we cannot read 100% exact this box plot, but at least 90% or 95% we can make a nice prediction. Here I can see that 200 minimum peoples are migrated in this area, right? This one. And this line and the top line, this line, these are called the whiskers. And now later on I will show you why we make this whiskers and what is the purpose. And this is the maximum. So maximum we can say 1300, right? Because it is above 1200, but not exactly 1300. Maybe it is 1290 or maybe a little bit more than 1300, but at least we can read that 1300 is the maximum people who were migrated, right? Okay, this point is called the Q1, means quartile 1. 25% of people from 1980 to 2013 migrated from Japan to Canada is here, this one. So here we can say approximately 500. Maybe a little bit more or less. I will show you, but we can read. This is called the median, means 50%. 50% of people from Japan migrated from 1980 to 2013 to Canada, which is approximately, you can say, 900, maybe exactly 900, right? If we have a exact scale here, maybe a little bit more or less, 900. And this is called the quartile 3, means 75% of people. So we can say approximately 1000 plus or maybe 1050 people were migrated, right? This is called Q3, 75%. This is Q1, 25%. So Q3 minus Q1, what is the number, is called interquartile range, IQR. Right, so this is our box plot. Now our box plot is ready. We can show to our audience, but here we will make more modification to our box plot. Whatever I told you I have written here, we can immediately make a new few key observations from the plot above. The minimum number of immigrants are approximately 200. Whatever I have showed there, maximum is 1300, median is 900, and so on. 25% is quartile 1. This is quartile 3. Right? Okay. Now we will use the describe function, which will give you the exact number. Right? So here, this is our data frame dot describe. So I will show you. As I said, the minimum number is 200 according to my graph, but here is 198. I said the maximum people were migrated in 75%, that is 1284, and I said 1300. This is quartile 1, 529, 902, 1079. So I will show you here. These are this one. Minimum number is 198. Right, here is 524 and so on. Right, so if you want to need the exact number, you can run the describe function, which will give you the statistical measures. I hope this is clear. Now move on to the next coding. One of the key benefits of box plot is comparing the distribution of multiple data sets. It's not necessary that you can make only one box plot at a time. If you want, you can make 2 or 3 or 4. So here I am going to show you 2 different countries. After that, you can pause the video and you can make 3 or consider 3 and 4 countries and make the box plot. So my question is, compare the distribution of the number of new immigrants from Sri Lanka and Poland for the period 1980 to 2013. Now we have to consider these 2 countries. So same thing, 2 steps. First step is we will see the data frame of Sri Lanka and Poland, and second step is we will make the box plot. So here I said my data frame name is df underscore sp. Whatever name you want, you can give to your data frame. Why I said sp, s is for Sri Lanka and p is for Poland. That is why. So if I will write down this coding, you can try, and I will run it again. There will be a mess in our graph. If you want that your year should be considered as an index, then you have to take the transpose, which we had discussed earlier. So this is my transpose, and I said top 10 here. So when I will run it, you will see Sri Lanka and Poland, and these are the 10. But when we will make the graph, it will consider from 1980 to 2013, all the years, and these are the numbers. So our data frame is here. Second step is we will see the describe function. If you want, you can see the describe function. Same thing, here is the minimum value 185, here is 1720. For Poland, maximum is 13,102, maximum for Poland is 17,040. And now we are going to make our nice graph. Everything is same when I will run it. So see here, I did not mention any color for my graph. So by default, the color is red. When I will run it, you will see a nice graph and the color is red. So this is the Sri Lanka and this is Poland, and you can make comparison. Here I will show you one interesting thing. These points are the outliers, and now you know very well what is the meaning of outliers, right? Okay, this is the maximum value of Poland, maximum numbers of Sri Lanka, and this is the minimum value. First of all, when we compare the graph, keep in mind we have to see this median and this median. See, this median is here, so easily we can see in this rectangle that this part is more bigger than this part. It means more people migrated in this period, because here we have more data here. Same thing here, the median is here. We can easily see that this part of the rectangle is bigger. It means more people were migrated on this area compared to this. If our median lies at center, right, or a little bit in center, and we cannot make the difference which side is bigger, then we will see these whiskers. These are called the whiskers. So this whisker is being big compared to this whisker. If this median is at the center, then we will make our decision on the basis of whiskers, and we will say our more data lies here. It means more people were migrated in this area compared to this area, right? Okay, this is my vertical box plot. If you want to make the horizontal, then what you have to do, everything is same. If you will read same thing I have written here, what I am going to explain you, only you have to use vert function. Vert is equal to false. Vert is equal to false means horizontally. If you will write down vert is equal to true, or if you delete it, by default you will see vertical. Right now it is your homework. You can check vert is equal to true. And here I have mentioned color is equal to blue, only to show you that you can change the color according to your choice, right? So color is equal to blue, vert is equal to false. When I will run it, you will see exactly the same graph, but now it is horizontal. When we were making our bar chart in our last lesson, right, we were using kind is equal to bar age for horizontal. But in box plot, do not write down box age, box and vert is equal to false, right? Then we can have, this is Poland, this is Sri Lanka, these are our outliers, and this is the graph. So it means we have more immigrants in this area compared to this. Here we have more immigrants here, right? Again, if this median lies at the center, we cannot make decision which side is bigger. Then we have to make decision on the basis of this whisker. Here this whisker is big, right? Okay. Now, another important topic of this box plot is subplots. Now what is the meaning of subplots? Subplot means that sometimes we want to make 2 or 3 different graphs. Just like this Sri Lanka and Poland, I said I want to see the bar graph, I want to see the line graph, I want to see the box plot. Then we can compare how the line graph looks, how the box plot looks, and so on. So this is called the subplots. And what is the syntax of subplots? First of all, we have to make our figure. Fig is equal to plt dot figure. And in order to make the subplot, we use the artist layer. As I have mentioned earlier, that there are 3 layers in Matplotlib: backend layer, artist layer, and the scripting layer. So far we did the scripting layer. In the scripting layer we were using PLT, right? But now we have to use access, and I will show you how it works, right? And then n rows and n columns, you have to write down here plt.figure. In this parenthesis we have to pass number of rows, number of columns, and number of plot. Okay, so here I have mentioned that n rows and n columns are used to notionally split the figure into n rows and n columns. Your job is to read it very slowly. What I am explaining is written here. Plot underscore number starts at 1. Increment across rows first and has a maximum of n rows multiplied by n columns as shown below. So see, here I have made one figure for you, this one. In the parenthesis, you have to mention how many rows. 2 rows, 2 columns, and this is always first plot. Maybe this is the box plot. Pie plot, this is the second plot. Line plot, this is the third plot. Scatter plot, this is the fourth plot. Right? But you can make 5 or 6 whatever you want. This is how it looks like and how it works. With the help of this coding, I will explain to you what I have said here. So first of all, fig underscore plt dot figure. We have to create the figure. Right? And this is my comment. I will discuss this later on. And then fig dot add underscore subplot. This is the syntax. And add underscore subplot, you have to pass 3 parameters. This is 1, 2, 3. Now what is the meaning of this? The first one represent rows, this is columns, and this is your plot number or graph number. Right? So these two should be constant. Here I am comparing only two plots, box plot and line plot. If you want the third, suppose area plot, scatter plot, then it will be 1, 2, 3 and 4, but it will remains the same, 1, 2, 1, 2. What is the meaning of this? It means here I am considering true plots, box plot and line plot. So I need one row, means in one row there should be both side by side, both plot, box plot and line plot. And these are the columns. Then we can have 2 columns. I will show you when I will run it, then it will be much more clear. One row, 2 columns, first row, 2 columns and second plot, and so on. So here, as I said, we are going to use the artist layer. So we have to say ax0 and this is ax1. If we have the third plot or fourth plot, which I will give you homework, then you have to write down ax2 and ax3 as well. And everything is same here. Word is equal to false. Color, this time I need green. This is my figure size. Ax is equal to ax0, right? And here I will show you my all the comments so you can see. When I will run it, it will be clear to you, right? I will show you. Now see Sri Lanka and Poland. Here is the box plot and here is the line plot. If I will say this is one row, this is one row and this is 2 column, 1 column and 2 columns. And this is plot number 1, this is plot number 2. See here. This one, first row, both are in one row and 2 columns. If I say 2 rows, 2 rows and 1 column, so instead of side by side, one will be on the first and then it will be on the second. See, I will run it, then I will show you. If I will say 2 and 1, then I have 2 rows. See now, it is 2 rows. This is one row, this is second row, and this is 1 column. So we can compare the same output by using 2 different graphs. I hope this concept is clear, right? What is the meaning of 2? So if I say 1, 1, these will be side by side. Your graph will be side by side. And this 2 will be same, but if I have the third, fourth, so you will write down 1, 2 and then 3, 1, 2 and then 4. Now one more thing. If your number of rows and number of columns and number of graphs are less than 10, then instead of writing 1 comma 2 comma 1, you can write down 121. Fig, now you can try this, right? Make this comment, remove this comment from here. When you will practice and run it, you will get the same output. 1 2 1 means one row, your all graph should be in one row and 2 columns, right? If you have a three graph, So what you have to write down 1 3 1 means one row, three columns and one first graph, here second and third. Now this is your job. You can add here pie chart or line, sorry, or the area chart. Everything should be same. Instead of ax1, then you have to write down ax2 dot set underscore label and ax3 and run it. And here you have a sign as well. What is ax2? Just like this, and ax2 and 3. In this way you will learn more. And here I am using the artist layer. That is why see set underscore title you have to write down axis and then set. In our scripting layer we were using plt dot x label, plt dot y label. Here you have to use in artist layer set underscore y label. This is the difference between the scripting layer, and a scripting layer is advanced compared to, sorry, artist layer is advanced. So I hope this is clear, right? And I have written the same thing here. In the case when n rows and n columns and plot number are less than 10, it is convention you can write down direct 211 or 3 digit. The first represent rows and columns and the graph number. If you will read it, it will really help you. Now I recommend you to pause this video, read this question, do your coding. After that you can match with my coding. In this way you will learn more. But I will show you one more question. Create a box plot to visualize the distribution of top 15 countries, right? Top 15 countries, but what is grouped by decades: 1980s, 1990 and 2000. All the countries, right, of 1990, the people were migrated from in 1980 in 80s, 90s and 2000. Again same thing. First of all you have to see your data frame. Here I am using sort underscore values of the total column which we had added in our data frame. That is why you have to see the pie chart video as well. The link I will provide you in the description. When I will execute this, so you will see all top 15 countries of each decade is there, right? Second is create a new data frame. This is the important point, how you have to write down your coding. Create a new data frame which contains the aggregate for each decade, right? First I have written create a list of all years in decade 80s, 90s and 2000. Please read this very slowly. I am going to show you how you have to write down this coding, right? If I missed anything here I will know. Okay, so create a list of all years in decade 80s, 90s and 2000. So these are our variables name 80s, 90s and this 2000. List map string, right? All are considered as a string for the sake of consistency. Range is 1980 to 1990. Here 1990 to 2000. Here 2000 to 2010. And here we are using the slicing. Slicing we have discussed in fundamentals of Python very well. And when you will run it, you will see the output. All the 15, all the countries, right, of 1980s, 1990s and 2000, which are migrated from different countries to Canada. If you want to see the describe function, just run it. It will show you the mean, standard deviation, minimum value, quartiles. Here, whatever you want, you can see and make your graph. If you want to make your graph, here I am not going to write down any color. By default, the graph will be red color. Figure size is 6 by 6, which represents width and height. If you want, you can change it. This is my PLT title and show when I will run it. So you will see very nice three different box plots, right? 1980, 1990 and 2000. As I did not mention vert is equal to false in my coding, that is why it is vertical. If you want to write down here vert is equal to false, then your graph will be in horizontally, and these 2 points are the outliers. Here I have written about the outliers. Then I will give you a simple homework. Note how the box plot differs from the summary table, means describe table. The box plot scans the data and identifies the outliers as well. But in here, in our summary, in here, we cannot see any outlier, right? But when we make our graph, it is outliers. So what is the outliers? larger than Q3. Q3 is quartile 3 by at least 1.5 times the interquartile range. What is the meaning of this? I said quartile in can be either direction, right? So quartile 1 is 17,451, quartile 3, which is 75%, is this. Subtract quartile 3 from quartile 1, which is called the interquartile range. I am just showing you how to find out the quartile. In if the data is available, right? How you know which number will consider as a outliers? So this is the formula, right? So from where I am getting this number, I will show you here. I am checking these number of 2000. Then you can do for 1980s and 1990s as well. This is 17,451, quartile 1. This is quartile 3. Quartile 3 minus quartile 1, which is called the interquartile range. Because in order to find out the outliers, we need interquartile range. So this is our interquartile range. Then outlier formula is Q3. This is Q3 plus whatever is interquartile range multiplied by 1.5 added 65,000. Means any number in your data set, if it is greater than 65,741, it will consider as a outlier. And this is for the bottom outlier. Same thing, Q3 minus 1.5, and your interquartile range is this one. If any point data set is less than 7,793, it will consider the lower outlier. This is the upper outlier. Now if you want to check, this is your homework. If you want to check the entries fall above the outlier, then you will say greater than this. If you want the lower outlier, then you have to say less than 7,793. This is your homework. You have to do it. It will be very easy. Only you have to run it. I want to involve you because when you will involve, you will learn more. So I hope the box plot is clear to you. Please practice it. Subscribe to my channel, share it, like, and see you in the next lesson. Thank you so much.